Good afternoon. So I want to talk about some of the decisions you have to make along the way of your GitOps journey and some of the consequences of those. So I'm not going to talk about any particular products. I'm not going to talk about any particular platforms. So the first thing I want to do is I want to talk about, hey, what do all these terms mean? Like, let's level set on what I'm going to actually talk about. There's two different things CD means, continuous delivery and continuous deployment. There's CI, there's GitOps. They're all a little different. So, for the purposes of this talk, when I'm talking CI, I'm talking about building your code to gain it in an artifact repo, unit tests, test automation, etc. When I'm talking continuous deployment, hey, this requires continuous integration, but it's not the same thing. So this is all about how do we get it the rest of the way into production? How do we actually get it on the right clusters, make sure everything deploys safely in the expected way? And when I talk GitOps, I'm talking about how do we make sure that people aren't doing this by hand? How do we make sure all of this lives in change control? We can audit who did what. We can easily roll back. So if you think about it, you can't do continuous deployment without doing continuous integration. You can technically do GitOps without doing either of them. So the very first time I saw a team doing something I would classify as GitOps, except for the fact that it predated Git, they were maintaining all of the deployments in source control, but they had customer-specific deployments. It was a per tenant application, and someone went in and modified a file in Git when a customer needed an upgrade. Was it continuous deployment? Were customers upgrading and getting features immediately? No, but it was GitOps. So these things are all related, but they're not the same. Personally, I think that there is a happy path a lot of companies want to get to, where they're doing both continuous deployment and GitOps. Some examples of where you might be doing one but not the other. Hey, GitOps has the word Git in its name. If you're not using Git, you're not doing GitOps. So if you're on Mercurial, not doing GitOps. It also, a lot of people consider GitOps to require that your configuration is declarative. This is something I happen to be a big believer in. If you're checking in a script, and if you modify that script, everything breaks, you're probably not really doing GitOps the way you want to be doing it. So your configuration of what you are deploying should be in a declarative fashion. Similarly, you might be doing GitOps and not be doing continuous deployment. If you're doing, a bunch of manual processes in the middle, you're, doing different repos, and, it's 3 months in between the original feature being committed and it actually being deployed to some environment. In the happy middle ground, all your configuration and source code is in Git, and I mean everything. Your infrastructure is managed as code too. Your deployments are managed as code. Everything is. And it's all declarative. If you're in the middle, when you check in a feature, it gets everywhere. It doesn't just update your dev environment, doesn't update staging. It updates staging, runs your integration tests, it updates production, it updates all of your regions. So that's kind of the middle ground that, from what I've seen, a lot of people want to be trying to reach. So we're going to talk about some of the problems I see people encountering along the way when they're trying to get there. So the first thing I want to talk about is repository structure. And the reason I want to talk about this one is I can't tell you how many people I have talked to who are like, I just like XYZ tool. And you start talking about why, and it's not actually a problem with the tool. It's how they configured the tool. So back before GitOps was a thing, back before DevOps was a thing, we came up with a branch management pattern called Gitflow. And it was originally developed for long-running releases you need to maintain. So if you have 5 versions you need to maintain for 2 years in parallel, it's a phenomenal way to manage your branches. And when DevOps came around, everyone was familiar with this way of managing branches. So they started going, well, I can do a branch per environment. And it looks really, really good on paper. If you're a small team, everything's simple, it works okay. The bigger you get, the more cooks you got in the kitchen, the more likely it breaks. Some examples of how it breaks. Imagine that you're using branches, and you want to run a different number of replicas in the staging environment versus a production environment. Okay, someone changes the image version, merges to staging. When you go and you merge it to production, it goes and picks up the replica set, the replica count change another person made, and you didn't even realize it. So, when you start doing branches per environment, it can cause a lot of pain. It causes so much pain, the creator of GitFlow actually went back to the original blog where they published it, and they wrote a disclaimer saying, don't use this pattern for this. It's not what it was intended for. Personally, I'm a big fan of trunk-based development. There's a few other alternatives out there as well, but check in your build on feature branches, check them into main. When you get to main, go ahead and ship that off to all the environments. So hey, what's the alternative to a branch per environment? My personal recommendation is make a folder per environment in your repo. I say a folder, not a file, for a very specific reason. You don't know what the future holds. So, if you're using Helm, you might be like, hey, I can just, I've got a values file per environment. I can have one name prod, one name staging. 2 years from now, if you suddenly have another file that you need, you're going to have 2 files with dash staging. You don't know how it's going to grow. Just make it a folder. It's easy. Grows better. And the other thing I'd recommend is there are a whole bunch of really good tools out there for doing templating for YAML, templating for JSON, templating for XML. These two are really common in Kubernetes. If you're using something else, I guarantee there's a template generator for it. So use tools like Helm and Customize. They allow you typically to have all of the definition of the application be shared, but then have parameters per environment. So you can go and you can have a file in those folders for each of those environments, and suddenly everything's going to be a lot easier to manage. The other one I see a lot of people struggle with and sometimes wind up regretting their decision on doesn't have nearly as cut of dry of A versus B trade-off, in my opinion. And that's how you structure your Git repositories. So, some people go and they put their applications and their infrastructure code all in one repository. Some of them do a separate repo per app, or an app repo and an infra repo. And my best piece of advice here is ask yourself how your company works. If you're a small team, you expect to stay a small team, the same people are doing infrastructure who are doing the app dev, one repo actually works really, really well for that. You don't have as much cognitive overload. If you're a 2,000-person company and you have controls on who's allowed to touch the AWS account configuration, doing multiple repos helps you enforce the separation of duty. You can more easily set up different permissions per. So ask yourself where you are now, but then also ask yourself where you think you're going to be in 3 to 5 years. Because restructuring repos kind of sucks. You don't want to have to do it. You know your company's growth trajectory. If you're building a consumer cell phone app, you're probably not going to wind up having a bunch of heavy InfoSec concerns. If you're a 10-person fintech startup, you probably are going to wind up needing those separation of concerns in the not-too-distant future. The next pattern that's out there that I want to talk about a little bit is push versus pull. So the difference here is when I check in that configuration change to Git, how does it get applied? Is there an external system somewhere that's monitoring my Git repo? Or is my CI system kicking off a deployment job? These are two fundamentally different patterns. Some of you may not be familiar with both. So if you use Kubernetes, there's a bunch of Kubernetes tools that use pull, but there's very little that uses the pull model outside of Kubernetes today. It's kind of the newer one. So some of the advantages of push is it's been around longer, it's a little bit simpler, more people understand it, and one of the things I really like about it is it leaves you with the full power of your CI system. So, if you are deploying something and you need to run YQ to change one thing as part of your build script, you can, and it's really easy. When you're doing a pull model, oftentimes going and doing scripted changes to config can become more complicated. The other thing I like about it is it's cross-target. So if you're only deploying to Kubernetes, hey, pull's not a problem. If you're deploying to 5 or 6 different things, and one of your tools is pull and everything else is push, that suddenly means your app devs, every time they have to touch one of these tools, is having to completely change their mental model. And the more things work in the same way, the easier it is to get your job done. I suspect a lot of people in this room are, on SRE teams. Think of the app devs as your customers. And, the more familiar things are to them, the more productive they're going to be, the happier your customer will be. There are some disadvantages of push. So there are push systems out there that require things like you load external secrets into GitHub. They require internet access to like a Kubernetes cluster. That's a problem. If you need external secrets, use the secrets manager. Don't check it into your Git repo. Everyone should know that. But also take a look at how it connects to your cluster. Because a lot of companies, when they start, when they're 10 people, maybe you can get away with having your Kubernetes cluster's API endpoints internet accessible, but it's not going to last. And you don't want to be poking holes in your firewalls for it. So how you actually connect the APIs you're deploying to back to your Git repo is a meaningful problem. And whatever tool you're using, make sure it's got an answer for that. On the push model, there are tools that run in the cluster, connect back, and then have frameworks where you can trigger it. On the pull model, hey, they're connecting to your Git repo and pulling from it, so as long as your Git repo is internet accessible, you're usually fine. Some of the other disadvantages of the pull model. It tends to have a large amount of business logic that you need to manage on the system that is applying your configuration. So one of the interactions I had with a customer once that kind of opened my eyes on this problem, it was a large bank, and they were trying to upgrade a pull model-based deployment system for 4 months. And that sounds conceptually easy, but the problem was they had 400 clusters. They had 4 different versions of this thing running, and all of the versions treated the configuration slightly differently. So anytime they tried upgrading any cluster, it broke someone else's config. So they couldn't get all the different teams on a single version that actually worked the same across everything. So make sure you think about that. So the next thing I want to talk about is automated validation. So we talked a little bit about GitOps versus continuous deployment. A lot of the tools in the space support both. My advice, if you want to get to where you're doing full continuous deployment, everything fully automated and not just GitOps, you want to make sure that the tool chain you are using has an easy answer for how it orchestrates deployments and testing across multiple environments. Very few people deploy to production immediately when someone checks in. They tend to deploy to pre-production environments. They tend to run integration tests. They tend to run security scanners. They only go to production if those pass. There are a lot of tools that, how do you know when it finished updating? So if you're on that pull-based model and it went and it updated staging, how do you know when it's time to go run the integration tests that need that environment to be deployed? Some of the tools have answers for that, some of them don't. If it doesn't have an answer, you're going to have to build it yourself. So make sure you think through that. Some of the push-based systems, you're having to go and monitor and wait for that deployment to finish, pulling constantly. GitHub Actions, if anyone's using it, charges you by the minute of execution time. You don't really want to be pulling and waiting. So, make sure that, not only can it tell, but it can tell in a way that's reasonable and not going to cost you an arm and leg. Some examples of the classes of tests you want to run. Some of the security scanners. So, I assume everyone uses Docker image scanners and static code analyzers. That's not what I'm talking about when I say security scanners. If you look at the OAuth scanners, a lot of them need a deployed environment to run, and basically just scan even the full web server. So those are the ones that you tend to need to mix in to your deployment pipeline. There's also end-to-end tests, smoke tests, Selenium, and all of that stuff tends to need everything deployed talking together. Another thing that is, in my opinion at least, extremely important if you want to get all the way to CD, at least if your product if stability is truly important to you for production, and it really should be important to everyone who's here, is when you are deploying to production, how do you make sure that if there's a bug you haven't found yet, you can detect it and automatically roll back? So a decent percentage of tools, but not all of them, have things beyond just, hey, shut down all of production, install the new version, turn it on, or an all-at-once update. And a decent percentage also have things beyond like a rolling update, which is the default strategy for Kubernetes. Rolling update basically like updates one pod at a time. And there's strategies beyond that. So I'm going to talk about two of them. The ones I'm going to talk about are canary deployments and blue-green deployments, which are basically strategies that help you both, in the case of canary deployments, decrease the blast radius of how many users are going to be affected by your deployment. And in the case of blue-green deployments, lets you actually validate that the specific copy of the application in production is working as expected before you send it traffic, and provides you the benefit of instant rollback. It does have one downside, which is you're running multiple copies of the app, so it costs slightly more. But if you're running this for 20 minutes, it's usually not a huge deal. So blue-green deployment, the core concept here is stand up two versions in parallel. So in addition to the old version, you stand up the new version, but you don't send it any traffic. You validate it. Depending on where you are in your GitOps and CD journey, if you're really early, you might be validating it by hand. There's a lot of people who are going, I can't do CD, I can't do GitOps. Like, everything's manual. Well, you know what? If it's manual, go put together the building block, have a manual approval, like it gets moving in the right direction, and then automate the manual approvals. So, stand up the new version, run some tests against it, look at it, make sure everything looks good, then send it traffic, then continue monitoring, check your monitoring, look at it, and make sure it doesn't fall over. And, keep that old version around for a while. Once you shut that old version down, how quickly you can roll back is limited by how long it takes your application to start. If your application's cloud native, hey, hopefully it starts in sub 30 seconds. If your application's some legacy thing that was built on VMs, it might take 4 or 5 hours. And that's a problem. So run them in parallel for a while, make sure everything's healthy. That's the core concept. There are some applications that this is not suitable for. It's not usually the cloud native ones, but there are applications out there that you cannot run multiple copies of. They usually have like an exclusive database lock or an exclusive file lock. So if you have an application like that, you might not be able to do this. But I would highly recommend making sure any CD tooling you are choosing and any GitOps tooling you are choosing has a reasonable way to get here when you're ready for it, because it will help you ship faster. The other advanced deployment strategy I want to talk about is canary deployments. To give you an idea for why this one matters, there's a company I know of who uses these, who's a payment processor. So they, they're like a Square. They run credit card transactions. If they ship broken code and their payments stop running, that suddenly means literally every single payment that doesn't run is costing them money and is frustrating their customers and losing them customers. Like, if that's your business, you don't want a new version of code to go to everyone immediately. So, they send 1% of their transactions through a new version of code for a while. I want to say it's something like 2 or 3 minutes. And then they increase it to 2%, go all the way up to 100. And what that does is it decreases the risk of shipping. So the whole reason why we're at CDCon, the whole reason we're trying to ship continuously is the smaller changes are lower risk. These strategies also help you lower risk. So there's various ways of implementing a canary strategy, but the basic idea is incrementally increase how much traffic is reaching the new version. Some people implement this at a load balancer. Some people implement this by dynamically scaling how many servers are running the application. There's a lot of options. When you're choosing a tool set, make sure that it has a sane option here. You can build it yourself if you have to. You can start combining 4 or 5 different tools. But the more of that you're doing, the the harder your final solution is going to be to maintain. You know, a lot of companies build really, really great in-house CD systems. Then the guy who built them leaves. And no one else knows how it works. And then something changes. And it's changed, breaks a little. Okay? It's fine for another few months. Someone changes it again, breaks a little more. So when you're looking at this stuff, ask, what's it going to be like when you leave? How do you make sure it's going to survive you? And how's your company going to grow in that time? Anyone have any questions they wanted to ask about GitOps, CD, et cetera? Yes, you in the back. Oh, sorry. I thought you raised your hand. Guess you were not. Oh.
So my question is, you know, when I have a lot to reconcile, right? How do I make sure that the time that the first deployment get the change to the last one that get that change? How do I make that time?
How do you make that time small?
Yes, yes.
So the best secret I have to making that time small is to automate every step, which tends to be hard, and run as many steps as you can in parallel. So a lot of companies have multiple different pre-production environments. So like integration tests and security scanners are often not in the same environment. I've worked for multiple companies where it's like the security scanners must run in this environment and you can't even have full control as an app team to this. Like, we own this, you can't touch it. But, you know, if you could run your integration tests and your security tests in parallel, hey, if either of them fail, you don't go on to prod. But suddenly you're not waiting. So, you know, if you're doing one then the other, it's going to be slower. When you hit production, there are a lot of people who deploy multiple regions in parallel. I have mixed feelings on this. It really depends on your application. The reason I have mixed feelings on this is, like, making changes is not with zero risk. And when your application is multi-region, there tend to be periods of time where different regions are have lower usage. So there's also companies who do, you know, maintenance windows and will, you know, update the EU servers at midnight Europe time, update the US servers at midnight US time. So if you want to be all the way to production as fast as possible, you do it in parallel. You can decrease risk farther by going, hey, the production environments update on, you know, basically once a day during a maintenance window. And since I said the first thing I said was fully automate everything, if you're not there yet, get the entire end-to-end flow working, even if it's got manual approvals. Look at how long each manual approval step takes, and then prioritize automating those steps based off how long they take. Does that answer your question?
Yes, it does.
Awesome. Yes.
Hi. I have a question in regards to, like, the approval of a commit in the GitOps way. So the friction I have is between, like, do we do approvals to go production on the PR level and let the branch do whatever it wants to, or do we let the commit go through into the main branch and then whatever CD pipeline we use, Argo, whatever, have a button say approve, go ahead?
Yeah.
What's your view on that?
So my opinion is that your PR review process should be having the code reviewers go, I believe this can go fully to production. So, like, when I review a PR, if I see anything that I think would keep it from running, I won't approve that PR. There may be automated tests that should always pass that haven't been run yet. So, you know, anything you're doing from, like, a code review level, when that PR merges, you believe it's ready to go to production. I'm a firm believer that you don't ask people to review your code until you believe your code will work in production. If there's tests that you need to run that need a deployed environment in production, there's a lot of companies who can use some of the GitOps and CD tools to, you know, stand up like a namespace in a Kubernetes cluster for a particular branch, spin it up. Hey, you can run your test suite there before it ever merges. So PR, that should be ready to go to production. Sometimes your scanners find something you didn't expect. So you may, after merging to production, have those things running. And if they detect a problem, they'll fail it. Hey, suddenly you need to go and fix that problem.
I've got two questions.
Okay.
First question is, are there any implications to doing both the Git push and the Git pull model?
I haven't seen a lot of setups that do both. The vast majority of the time, people are doing one or the other. So my product does the Git push model, and I've talked to multiple people about like, hey, we can push back so that you can have something else that's using the Git pull model at the same time. I haven't found a huge amount of interest there. There are a couple tools that are beginning to do that, where they're doing like a orchestration layer that writes back to Git. But it isn't widely adopted yet, and I haven't seen enough of it in the wild that I think we know what its problems are yet, if that makes any sense.
Thank you. My second question would be on maintenance windows. Is it industry standard to run the maintenance windows just off work hours or off, I guess, where most customers are online on the application?
So I'm not sure it's fair to call it an industry standard. It really depends on which industry you're in. Some industries do maintenance windows, some don't. So like a lot of enterprise software does, where your companies are other software companies, and where you're doing a SaaS solution does maintenance windows. I've talked to a decent amount of like consumer tech that doesn't. When you are doing maintenance windows, there's two ways people do it. And I happen to have a very strong opinion of which way is the right way. So the two ways I see people do it is, we do it at a time that works well for our internal engineering team that isn't 5 p.m. on a Friday because, hey, this is a time that like fits in our schedule. We can block it off easily. It's in our normal workday. And then the other one that I see is, this is a time when most of our customers are not using it, so it's lower risk. Personally, I believe the latter is what you should do. It's far and away what I see most people doing. But I do occasionally see people who try and schedule maintenance windows, not around what's right for their customer, but about what's right for them internally. And I don't think you should do that. Does that answer your question?
Yeah, thank you.
Yeah, no problem.
In many traditional systems, we have a Git branch strategy, such as a Git flow. And how do you manage your Git branch with CD?
So you might have walked in after I talked about it, but I am very adamantly against using Git flow for like environments. I am of the opinion that if you are doing a single repo, you should basically have feature branches, they merge to trunk, and then once it's on trunk, the goal of your trunk branch or your main branch, depends on which repo you're on, sorry, I'm old, is get it out to all environments. When I see people doing a branch per environment, that's like the single biggest thing that I see people do, where half the time the tool that they're going, this tool doesn't work for me, it's forcing me to do these branches this way, and it's bad. Like, half the time they're saying that about a tool, and the tool doesn't actually force it on them, it's how someone configured it years ago. So Git flow is wonderful for managing long-running versions. I would strongly advise not using it for like a branch per environment. I would use mainline for this is staging and production. Does that answer your question?
Yeah, but it reminds me of another question. So generally, in our company, we have dedicated QA teams, and generally it takes more than a week or months to verify a certain version. So the developer team should add a new functionality or new features while the previous version is being verified. So in this case, this is where we require the branch strategy. So in case of CD, how do you manage such cases?
So the best pattern I've seen for long-running QA, and a former employer of mine, we had a monolithic code base that we wound up ultimately migrating to Kubernetes. But to give you an idea of just how customizable it was. It had 4 different proprietary programming languages in it. The place we found bugs was literally stand up every customer's configuration, calculate it, and make sure all the numbers are the same. And we had customers who took 2 days to calculate for a single customer. So what we wound up instituting was we had a kind of a, like, basically 2 mains. So we had, this is the main that is currently in the process of trying to ship, and then we had a main, I forget what we called it, that was, this is the next one. So everyone merged their features into the this is the next one. And the ultimate main branch was updated on a schedule from the next main branch, and if you missed the day when that cut, your feature didn't make the next release. And you know, at that point, in order to ship faster, it was, okay, how much hardware are we willing to throw at the problem to run customers in parallel through this really, really slow testing process? So, you know, if you have to run that slow, I would say have kind of a branch before main that you merge to, cut off main when you're ready to start the large testing process, and manage it via schedule. Make sure everyone knows the date. This is when it moves. If you miss this date, you miss the release. And then you have your hardening period. But I would also strongly recommend do everything you possibly can to make that hardening period shorter.
Okay, thank you.
Yeah, no problem. Anyone else have anything?
Hi, just another question. What is your recommendation in terms of the triggers for promotions of deployments when you move from dev, stage, UAT, production? Like the teams I work with, they love the whole do a huge GHA pipeline and automatically promote, have it pause and so on. Like, what's your recommendation for that triggering to promote that artifact?
So in an ideal situation, your SDLC should have a set of things which need to happen in each environment before the code can move on. So we need these tests to pass, as an example. We need these people to sign off. You should be able to define kind of that list of constraints of what needs to happen in a declarative way. And once that list of constraints has happened, it can move on. If you think about things like maintenance windows, conceptually it's just a constraint that says, hey, this environment can only update in this time of day. So, you know, my personal opinion is, like, if you haven't solved that yet, go, okay, what's the goal of this environment? What needs to happen before it can move on? Figure out your environment order. Hey, this environment, it can't start till this environment's done. And after you've defined that list of constraints, you've basically defined everything you need to do to deploy. And personally, I like the constraints model where you're going like, this needs to happen. Significantly more than like scripting, because it's more change resilient. So some of the tools out there, you can actually implement things as this list of things needs to happen, as opposed to like you're writing a shell script. And they are a lot more change resilient in my experience. Any other questions?
Are you seeing, in your experience, are you seeing people when they're doing something like a canary deployment, or even blue-green, but just in general, when something goes wrong, do you see people rolling forward versus rolling back? I mean, in a Kubernetes native environment, it's always, you know, the natural thing would be, well, let's just point to the older version of the image. Mm-hmm. Or are you seeing more, okay, let's fix the problem, rebuild it, and redeploy? Which one are you seeing more?
So I see both. So when automated deployment tooling detects the problem, you usually roll back. And if you're using any good GitOps tooling, any good CD tooling, it should have like a one-click automated way to roll back. On the roll forward, okay, cool, you roll back prod. How do you go about fixing it? Where I tend to see the roll forward is, okay, cool, we've mitigated the risk enough, it's not a problem. We're actually going and looking at the bug. Let's go ahead and fix the bug. It's drop everything. Like, we're not just abandoning that branch. We're not rolling back main. It's all hands on deck, let's fix main, and then you roll forward that change. So it tends to actually be a hybrid most of the time. Like the per environment tends to be a rollback, but the Git side of it tends to be managed as a roll forward. Did that answer your question? Yes. Okay. Anyone else have anything? Awesome. Well, thank you everyone for coming. If you have any questions or want to talk more later, I'll be out at the Armory booth. Happy to talk more.